Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. Today, we're here with Lesson 101. We have broken the 100 barrier. We had a little party last time, and now we're on 101 Factorable Denominators. Now, this is where math really gets fun because we are learning to subtract and add rational expressions, which, remember, rational expressions are just fractions. But instead of just having a single number, the fractions are made up of polynomials, okay? So here we have a trinomial on the bottom and a monomial on the top, and here we have a binomial on the bottom and a monomial on the top. Now, in order to subtract fractions, we know that we must get a common denominator. And that doesn't change. So we're going to have to get a common denominator between these two denominators. In order to do that, we really need to know what this denominator is made from. Now, I'm going to guess that my book does not want to make this too difficult. So I'm going to guess that x minus 4 just might be one of the factors. So I'm going to try that as a first guess. I'm going to say x minus 4, because 4 does go into 12, doesn't it? So if that were the right factor, and I'm just hoping that it is, this one over here would have to be x plus 3, okay? Because negative 12 divided by negative 4 is a positive 3. So now let's FOIL our good guess and see if we get this polynomial. Okay, remember when we FOIL, we do first, outside, inside, and the last. And if we do our FOIL correctly, we come up with our cute little Martian man, Hermie. And let's write those down. So first would be x squared, and outside would be negative 4 times x, or negative 4x, and inside would be 3 times x, or positive 3x, and last would be 3 times negative 4, which would be negative 12, and when we take a negative 4x and a 3x and put them together, we get a negative x. So we were right. And I just took a hint from what was over here and hoped that maybe that was one of the factors of the trinomial. Now that I have factored this trinomial, I know what I need over here to get a common denominator. So what I'm going to do is I'm going to say x minus 4 I already have. So I'm going to multiply by x plus 3 here, x plus 3. But if I multiply the denominator by x plus 3, don't I have to multiply also the numerator by x plus 3? Okay, so I'm going to do that multiplication now. Okay, so I erased my board, so I had a little bit more space. And I know that this denominator is x minus 4 times x plus 3. So now I'm going to just write this whole numerator. So 6x minus p times x is px, minus p times 3 is minus 3p, all over this common denominator, which is x minus 4 times x plus 3. And if I look at this, there is nothing really that I can do to simplify that. 6x minus px minus 3p. None of those are like terms. So I'm stuck with that as my numerator. Now, your book multiplies this back together. That's entirely up to you. I allow my students to leave their answer in factored form. So whether you wrote x minus 4 times x plus 3, or whether you changed it back to x squared minus x minus 12, I would have counted either one of these as a correct denominator for that problem. So there is problem number 1. Get the light off the board there. Can you see it? So 6x minus px minus 3p over either one of those denominators is the answer. Okay, here's our second example. And we have a denominator that is a trinomial and a denominator that is a binomial. And I'm going to factor this one first to see if I get a good hint for this one. I'm going to pull out the x and make this x minus 6 times x. And then I'm going to say, well, let's just see if x minus 6 is one of the factors. If this were one of the factors, the other factor would be x plus 1. So let's FOIL this together to see if we get x squared minus 5x minus 6. So first is x times x, which is x squared. Outside is negative 6x. Inside is positive 1x. And last is negative 6. Okay, so this negative 6x plus the 1x does give us the negative 5x, x squared minus 6, and we have it. So this factors as x plus 1 times x minus 6, and this factors as x times x minus 6. Now we have a little problem. We must get each denominator the same. So this one, if we're going to make one common denominator for the whole thing, it would have to have an x plus 1, and it would have to have an x minus 6, and for this denominator to fit in, it would also have to have an x. So this is what we're going to call our least common denominator. This is the one that we're heading for. So let's look back up here before we erase anything. What is this denominator needing in order to match this one? It's got the x plus 1, it's got the x minus 6, but it needs the x. So in order to make this one fit the one we desire, we're going to have to multiply the numerator and the denominator by x. Then it is the least common denominator that we want. Now we're going to have to do the same thing over here. We have the x that we need. We have the x minus 6, but what we're missing is the x plus 1. So we're going to multiply the denominator by x plus 1 and the numerator by x plus 1. So now we have our little roadmap for what we're going to have to do. We have to multiply this one, 7x, we already multiplied it in, and this one we're going to have to distribute, and we're going to put all of that over now this common denominator that we have assured is the same on both. So now I'm going to clean up the board a little bit and come back and find our final answer. Okay, so we have 7x minus 5 times x minus 5 times 1 over, and then we have all the denominators. So this denominator is just the same thing on both sides. So x plus 1, x minus 6. Now, we can simplify this numerator. We have a 7x minus a 5x is a 2x minus 5 on the numerator. And then we're going to have x plus 1, x minus 6, and I ran out of room. This denominator, I just put it over there, but it's easier to see right there. So 2x minus 5 over x times x plus 1 times x minus 6. Now, this time, your book left it in this factored form, which is how I would do it. I like to leave things factored because there really isn't a good reason to multiply them back together unless specifically your book tells you to do it, and then you do it. Okay, so here is example 3 and last. We only have 3 examples in this one. Then we'll have 2 practice problems, and we'll be done with lesson 101. Okay, so here we're going to factor this one. Now, I'm going to factor it without the hints. Okay, I'm going to factor this one to get a hint. But first, let me show you how to factor it if you don't have a hint. So if I were going to factor this one, I would say, okay, this last one is going to be made up of the last one here and the last one there multiplied together. So I know I only have so many choices. I know that 6 times 1 is 6. Okay, so 6 times 1 or 3 times 2. Those are really my only options. Now, it's a -6, so one of them has to be negative. One of the factors has to be negative, and one of the factors has to be positive. Okay, I know that. Now, I'm going to look at, since that's a negative, that means that this middle term is a difference instead of a sum. So I'm going to say I want a difference of 1. So I'm going to choose 3 and 2 because 3 minus 2 is 1 and 6 minus 1 is not 1. Okay, so we're going to choose 3 and 2, 3 and 2. I want the middle one to be positive, so I want my 3 to be positive and my 2 to be negative, and then I'm just going to throw my x's on there. Now I'm going to FOIL to make sure that it equals what I wanted it to equal. So x times x is x squared, and 3x minus 2x is x, and 3 times -2 is -6, and it works. Okay, so that's how you do it when you don't have a cool hint like I'm about to give you over here. I'm going to step over here to this other one, this other denominator, and I'm going to factor out an x. And when I factor out an x, I can see I have an x plus a 3. So I'm saying if the author was being very, very kind when he made up these problems, he would let x plus 3 be one of the factors, which is exactly what happened. Now, we have to build the least common denominator. Okay, so when we're building the least common denominator between these two denominators, we're trying to find the smallest denominator that both denominators would fit into, okay, or be factors of. So x plus 3 would have to be in my least common denominator. X minus 2 would have to be in my least common denominator, and x would have to be in my least common denominator. I'm going to put the x on the front just because I like to, okay? And then x plus 3, but we already have an x plus 3. So this is our least common denominator, which means we have to take each one of these denominators and multiply by something to get this least common denominator. So we already know that the factors of this one are here. We compare these factors to the new factors we want. X plus 3, x minus 2. What we're missing is an x. So we're going to multiply this numerator by an x, and we're going to multiply this factor denominator by an x. So now this one's all ready. It has the numerator. We're going to have to distribute, but I've already made the adjustments. So then I look over here, and I have an x and an x, and an x plus 3, and an x plus 3. What this one is missing is an x minus 2. All right, so I don't have a lot of room, so I'm just going to throw x minus 2 down here and x minus 2 up there. Remember, I always have to multiply the numerator and the denominator by the same non-zero quantity. So now I have this one matching the least common denominator and this one matching the least common denominator. And remember, when I'm adding or subtracting two fractions that have a common denominator, I only need one of the denominators, and I'm just going to what? Multiply this together, and subtract them, and that will be my new denominator. So I'm going to clean up my board, and we're going to do that. All right, so here we have the new denominator and the new numerator. So let's go ahead and distribute that. 4x times x is 4x squared. 2 times x is 2x. And then we're going to do the minus 4 times the x, which is minus 4x. And then the minus 4 times the negative 2 is a positive 8. And now we're going to fix this all. So 4x squared, 2x minus 4x is negative 2x, plus 8 over x times x plus 3 times x minus 2. Now, that would be fine to leave it that way, But we do need to make sure that this numerator does not factor in such a way that one of these denominators would be in there. So I can pretty much mark off the x because there's not an x in each one. And I can mark off the x plus 3 because there is not an x plus 3 in each one. Okay, so I mean, there's not a 3 is not a factor of 8. So I went, okay, I know it's not one of those. But x minus 2 is at least a thought, right? So if we did have x minus 2 here, then what would have to be the other one in order for it? So we're going to see, does this divide by this evenly? And it does not because of that 4 right there, and because that would have to be something different. So basically, if we had this right here, an x plus a 4, oops, a minus a 4, we have a minus, and that's going to be bigger, and that 4x squared. So this does not divide by x minus 2 evenly, and therefore, this is the correct answer, and we don't have to simplify it any further. So let me put that a little closer so that you can see it. And it is as easy as that, and as fun as that. I really enjoy these problems. So now we're going to do our practice problems. All right, everybody, so here's our practice problem. Copy it down, then pause your video and see if you can do it by yourself before you get a hint from me, okay? So go ahead, pause your video. All right, here we go. We're going to look at this over here, this simple denominator, and we're going to say, is there a possibility that that simple denominator is a factor of this more complicated trinomial? And since 7 goes into 21, it is possible. So I'm going to take that as a little hint, and I'm going to try those factors first. I'm going to write down x minus 7 in good hopes that that is one of the factors. If it were, 3 is what is needed to make 21, right? So I'm going to say plus 3x plus 3. And then I'm going to FOIL it to see if I happen to get it right the first time. So x squared, and then 3x minus 7x is minus 4x minus 21, and it worked. Okay, so these are the correct factors for my least common denominator right there. So all I have to do is, this one needs no alteration at all. I need to take my x minus 7. I'll put parentheses around it, and I'm missing the x plus 3. So I'm going to multiply the denominator by x plus 3, and also the numerator by x plus 3. This one's a pretty simple one, isn't it? One of the denominators actually stayed the same. So now we're going to rewrite the whole numerator over the single common denominator. So we have a 9x minus 7 times x is minus 7x. Minus 7 times 3 is minus 21 over x minus 7, x plus 3. Okay, so now we have this, will simplify a little bit. 9x minus 7x is 2x minus 21 over x minus 7 times x plus 3. X minus 7 times x plus 3. It's a little bit small, but maybe you can see it. So that would be my complete answer. And since 2x minus 21 is not one of these factors, I'm done. It can't be simplified at all. There is your answer to your first practice problem. One more problem and done. All right, here we go with the last practice problem. Copy it down and then pause your video, go do it on your own and see if you got it right. Okay, so the first thing is factor, factor, factor. We got to factor this denominator and this denominator. So we're going to, we could factor this. The factors of 9 are 9 and 1, or 3 and 3. Now, let's go get a hint from the other side of the problem. Let's factor x squared minus x into x minus 1. Okay, so I'm going to take a hint, and I'm going to say, could x minus 1 be one of these factors? If it were, let's try it, x minus 1. We know x is not one of those factors because there's not an x in every term. But x minus 1 could be. If it were, then 9 divided by negative 1 is a negative 9. And we'll try x minus 9 times x minus 1. So when we FOIL it, we get x squared. We get a negative 9x minus another x is a negative 10x. And then a negative 9 times a negative 1 is a positive 9. And it works. So this is the correctly factored left-hand denominator. And this is the correctly factored right-hand denominator. But notice that each one of them is missing something that the other one has. So the first thing we're going to do is we're going to build our LCD. And our least common denominator must have an x minus 9. And it must have an x minus 1. And it must have an x, which I'm out of space, so I'll just write it there. And then an x minus 1, but it already has one. So now our LCD is this right here. Okay, least common denominator. So now our next job is to make each denominator look like the least common denominator by multiplying something in. This first denominator on the left, x minus 9 matches, x minus 1 matches. All I need on this one is an x. So we're going to make a little space here and multiply the denominator by an x. And then we're going to multiply the numerator by an x. And we have the left-hand side adjusted. So now we're going to go to the right-hand side and get a little working space here. We have an x, which matches the x. We have an x minus 1, which matches the x minus 1. The only thing missing is an x minus 9. So we will multiply the denominator by x minus 9 and the numerator also by x minus 9. Okay, so we have done adjustments on both the left and right. And so now all we have to do is the math. So let's take, remember, this denominator is now our LCD, and this denominator is now our least common denominator also. Therefore, all we have to do is simplify the numerator and put it over the common denominator. Okay, so 4x minus 5 times x, and a minus 5 times a negative 9 is plus 45. Okay, so now all I have to do is simplify that. 4x minus 5x will simplify to negative x plus 45 all over this common denominator, which I'm not going to try to write again because I'm out of space. So negative x plus 45 over x minus 9 times x minus 1 times x. And there you have Lesson 101 in its entirety. And this is Mrs. A, and may God bless your day.